Hi again, welcome to TYB Teach Me Linux series. My name is Zeel and today's topic is going to be booting and shutting down the system. So in the last few lectures we have already discussed the duties of system administrator and understanding the file system structure. Today's topic is going to be based on bootloaders which are grub and lilo. This is going to be an interesting topic. So with this, let's dive in. Whenever you want to use your system, typically you press the power on button. You wait for a minute or two until the login screen appears. But have you ever wondered what happens between these two stages? If not, this is what we will be studying in today's lecture. So with this, let's start. When you switch the power on button, the very first thing that happens is your power supply will convert your alternating current AC into DC. Now, as we know, most of the electronic components needs DC. Therefore, the power supply will convert from AC to DC and then it will supply the DC to all the components which are attached to your system. Now, these components include your CPU, memory, CD-ROM, DVD drives, your mouse, your keyboard. So as soon as you turn on your computer, you can see a red light flashing over your mouse. So that indicates that the DC power is been supplied. So when the power has been supplied to your CPU, the very first thing that happens is your CPU will execute a series of instructions. The very first instruction is to call BIOS. BIOS is basic input output system. The main aim of BIOS is to check the integrity of all the components which are attached to the system. So let's say if you don't have a RAM attached to the system, so BIOS will check if all the components like RAM, hard disk drive, CD-ROM are properly attached, and if they are not, it will display you a message that this thing is not attached properly, please look into it. So we'll look into this with an example in the next slide. After CPU passes the control to BIOS, the first thing that BIOS runs is a test called POST. POST stands for Power on Self Test. So it basically means that BIOS will check if all the components in your machine are properly attached. So for this, BIOS will send an electrical signal to all the components in your machine. If it gets reply back, then it assumes that they are connected properly and are working. If it doesn't get reply, it assumes that they are either not connected or not working. So in this diagram, we can see a BIOS screen, and during that it displays information related to your CPU, memory, DVD RAM, and later it is trying to detect IDE drives. IDE is generally your hard disk. So let's consider a scenario where you don't have one of the components not attached properly. So suppose you don't have a keyboard attached properly. So BIOS will not get a reply for the electrical pulse it had sent to keyboard. So BIOS will display a error message saying that keyboard is not attached properly. So we have one of the screenshot for similar example. So here we can see that BIOS is showing an error message saying keyboard error or keyboard not present. And a funny thing is it is saying press F1 to continue. Well, if keyboard is not present, you cannot press F1, right? Anyways, so you might have also seen this typical screen. This is a BIOS setup. So what you basically do when you want to change settings or when you want to swap between the bootable device like CD-ROM or hard disk or even USB drive, you go into the BIOS setup and change the appropriate setting. So this is all about bias in a very simple way. We are not going into too much detail. So let's go to the next slide. So as we have seen, the very first function of bias is power on self-test. After the post is completed, the second function of bias is to select the first boot device. So suppose you have a USB drive and a hard disk drive attached to your laptop, and both has an operating system inside it. Now which operating system will bias try to boot in would depend on which is the first boot device. So whenever you install a new operating system from a CD, you have to select your CD-ROM as your first boot device. So the people who have been installing operating system might know about this. So in this diagram, we can see that this is a CPU slot. So whenever the CPU gets a power, it then sends the control to the bias. Bias in then performs the post and selects the first boot device. Later, it then sends the control and the information back to the CPU. Now CPU knows which is the first boot device. So let's say this is a hard disk and this is selected as a first boot device. Now, CPU will try to search for a master boot record inside hard disk. Now, MBR generally is located at the first 512 bytes of your hard disk drive. However, in many of the manufacturer, they also place MBR at the end 512 bytes instead of the start one. So it depends upon the manufacturer. We will be looking into MBR in the next slide. So this is one of the diagrams of or a screenshot of a BIOS. If you open up your motherboard, you will have a BIOS chip inside it. BIOS is a read-only memory, so you won't be able to write inside it. So let's go to the next slide and look at MBR in greater detail. So we have seen BIOS. The next step is master boot record. A bootloader generally contains information which is of greater size. As we know, the master boot record is only of 512 bytes. So it is not possible to store all the code and information in the master boot record. So in MBR, the first 446 byte stores the location of the main boot loader. So the first 446 bytes stores information and the location of the main bootloader. So your CPU will read the 446 byte and it will analyze the location of your main bootloader, and after it analyzes the whole MBR, it will then go into the location of the main bootloader and it will place it inside a memory. So as we have discussed, the 446 byte is for the location of the bootloader. The next thing is a partition table. This is of 64 bytes and each partition is of 16 bytes. If you are not aware about partition related information or partition table, we might be discussing this in the later slides, or I will suggest you to Google it. So we have 4 primary partition. The reason why is each partition is of 16 bytes. So 16 into 4 is 64. So there can be only 4 primary partition. If we want to extend it, we can have logical partitions. We might do this when we are doing file partitioning schemes. The next thing is magic number. Magic number in a simple term is used for validation of your master boot record if it is correctly configured and things like that. So after your CPU analyzes the whole master boot record, it goes into the location specified in the MBR. It go and it calls it inside RAM. So this location is then called and it is placed inside RAM. And after the main bootloader is placed in RAM, you will be able to see screen such as this. So this screen indicates that the main bootloader has been transferred into the RAM and is now ready to function. This is also called as kernel loader because during this stage the kernel is uncompressed and initialized. So with this we will go into the practical session where we will be looking into all these stuff practically and into much more detail. So in this practical session, we will be looking into basics of bootloader and master boot record. So let's start. So as we know, bootloader is a program, you can say, that is used to load the kernel which is located in your hard disk drive into your memory. Now memory can be your RAM. So without bootloader your operating system won't boot. All the operating systems including Windows has some kind of bootloader associated with it. As far Red Hat is concerned, the default bootloader is Grub. Now Grub works in two stages. The first stage is the master boot record, which we had discussed in the previous slide. The main aim of master boot record is to call the stage 2 bootloader. Problem with stage 2 is the size is bit more, so it cannot fit into the master boot record, which is of 512 bytes. So we need to insert a small amount of code that can call the bigger code which is located in your hard disk drive, and this is what MBR does. So let's look into your master boot record. Let's do a DD. Input file will be my hard disk drive. Output file would be, let's call it MBR, and byte size would be 512, since we know that the MBR is of 512 bytes and count is equal to 1. So all record copy. So let's analyze MBR. Okay, so let's open a diagram which we had looked into previous stages. So here we can see MBR in total is of 512 bytes. The first 446 bytes stores information related to the location of the stage 2 bootloader. The next 64 bytes contains information related to the partition table. So maximum you can have 4 partitions, and the last 2 bytes includes the magic number which is used for validation. So let's compare it with our entry of MBR in our operating system. So initially you can see it is showing information related to stage 1 and stage 2 bootloader. Along with this, it is showing information saying that it is a grand unified bootloader. Now whenever you install Grub, it is important to know that Grub will replace a default MBR with its own code. So we can see Grub unified bootloader over here. After this you can see partition related information, which is this. I'm not able to load image. Okay, which is this partition table. So here we can see we have 3 partitions: partition 1, partition 2 and partition 3. So these are these 3. I don't have partition 4 right now. So let's compare it with fdisk output. So here also you can see there is one partition, second partition and third partition, and all the information related to this partition is displayed over here, like the start sector, your end sector, etc. Now among all these partitions there can be one active partition. That active partition basically means that you have a kernel over there which your bootloader will be calling from. So from fdisk we can see that SDA1 is your primary partition and this is bootable. Bootable means active, and here you can see it is active. Active and bootable means the same thing. Let's compare other fields. Here you can see ID is equal to 0x83, and same thing you can find in the fdisk output. For swap partition ID is 82, and here also you can find 82 as your ID. So this is all about basics of MBR. We won't be going into too much detail as it's not in your portion. Let's go and look into the stage 2 bootloader. So the configuration file for that is in boot grub.conf. Now as we know, grub is in two stages. The first stage is MBR, which we just recently looked into. The second stage is the main bootloader, and this is the configuration file for the second stage bootloader. So we'll analyze each field in detail in the theoretical session, but let's look at some field right now. Here you can see kernel is VM Linux. So basically this references the kernel which is to be loaded. So let's find where the kernel is located. It has to be under boot. So this is the kernel which the grub configuration file is referencing into. So whenever we select a particular operating system, the grub looks at a configuration file, and in that configuration file it has a kernel associated with that. So with our current configuration file we have this kernel associated with this. So this kernel will be loaded into memory. Once it gets loaded into memory, it uncompresses itself, it initializes, and later after some time you can see a beautiful login screen. So I guess this is all about the practical session for now. We will look into theoretical session and will analyze each of the field of grub configuration file in bit detail. In the practical session, we have already looked into master boot record, and also we had analyzed the grub configuration file. So let's analyze the grub configuration file in more detail. Before doing that, remember the grub configuration file is under the boot directory, and the configuration file is generally grub.conf. So in exams, you'll have to write that grub.conf file can be found under boot and the name of grub.conf file. So let's go to the next slide. So let's analyze each of the option in the grub.conf file in bit detail. So the very first option is default is equal to 0. Now remember, in Linux the numbering scheme starts from 0. So 0 to 9 effectively is 10. So 0 is number 1. So here 0 means this operating system. If you have multiple operating systems over here, then the second one would be 1, 2, 3 and so on. So by default, the first operating system is selected. If you have default of 1, then second operating system might have been selected. The second option here is timeout. Timeout basically means how much time the grub should wait for user input before it selects the default option. So here it's saying timeout is equal to 10. So Grub will wait for 10 seconds for user input. If user does not provide any input, then the default option, which is the Fedora operating system over here, will be selected. The third field is splash image. Splash image is basically the background image that you are seeing over here. This background image is basically the splash image, and this thing is the location of the splash image. Now you can customize this splash image to whatever you want. You can have your own photo over here, right? The fourth option is title. Title basically indicates what should be the title that should be displayed in the grub menu. So here as we can see, the title is Fedora 2.6.x, and you can see the same title in your grub file. Instead of Fedora, you can also use a custom title like your name. So instead of Fedora, your name will be displayed in the grub menu. The next option is root. Now this basically indicates where your kernel is located. So here it says it is located in HD0 indicates your hard disk drive, and 0 indicates first partition. So remember the scheme, 0 indicates the first partition and HD0 indicates your first hard disk drive. This kernel option basically is referencing to the kernel that will load. So when you press enter on Fedora, the grub will load this VM Linux kernel into the memory and the initialization will take place. At last, we have the initial RAM disk. You don't have to know what a initial RAM disk is, but in a very simple terms, initial RAM disk is used to compile or you to give module kernels to the Linux. So when Linux is loaded into RAM, it does not have all the compiled modules. So during that time, initial RAM disk will provide the appropriate compiled drivers necessary to access the file system. So this is it about grub configuration file. In your exams, this much is more than enough. You don't have to go into too much detail. But if you do, you can do after your semester exams. So with this, we'll close this session for today on bootloaders. I won't be going into Lilo because if you have understood grub, simple reading of Lilo would be more than enough. However, I'll be posting the difference between grub and Lilo because it is important in terms of your exams. So I hope you have liked this video. If you have any comments, questions, you are free to post. I'm very open to criticism, and thank you very much for watching.